In the ocean, there is a very simple rule. Everything hunts, or gets hunted. Speed matters. Teeth matter. Strength decides survival. But sometimes, nature breaks its own rules. Because in the deepest parts of the ocean, there is a predator that doesn't chase, doesn't roar, doesn't even look alive. And yet, entire creatures disappear because of it. No struggle. No sound. No trace. Just silence. At first, scientists didn't understand what they were seeing. Cameras lowered into the deep ocean would capture something unusual. A faint shape. Stretching endlessly into the darkness. Too long to be a single animal. Too organized to be random. It looked like a drifting thread of light, fragile, almost delicate. But this is where things get strange. Because this thread can grow longer than a blue whale. And it isn't one animal. Not really. It's something far more bizarre. This is the siphonophore. A creature so strange, it challenges how we even define life. Because what you're looking at is not a single organism. It's a colony. Thousands of tiny, specialized units, called zooids. Each one is alive. Each one has a role. But none of them can survive alone. Together, they form something that behaves like a single creature. Like organs inside a body. Except, each organ is its own living animal. Imagine if your heart, lungs, and brain were all separate creatures, working together to keep you alive. That's what a siphonophore is. And in the deep sea, this design is devastatingly effective. To understand why, you have to look at how it hunts. Because it doesn't hunt like anything else. No chase. No attack. Just waiting. Stretching out from its body are tentacles. Long, thin. Almost completely invisible. Some can extend over 30 meters. Floating silently, like strands of glass in the water. But these are not harmless threads. They are weapons. Each lined with thousands of microscopic harpoons. Called nematocysts. And they are among the fastest biological mechanisms on Earth. When triggered, they fire instantly. No delay. No warning. In less than a millisecond, they explode outward. Piercing whatever touches them. And injecting venom. To a small fish, this is catastrophic. It's like being hit by thousands of hypodermic needles at once. Each delivering a dose of paralysis. The nervous system shuts down. Muscles freeze. Movement stops. All before the fish even realizes what happened. And here's the terrifying part. The fish never saw it coming. Because the siphonophore doesn't need to be seen. It doesn't need to chase. It turns the ocean itself into a trap. Imagine swimming through open water. Nothing around you. No predators in sight. Then suddenly, you drift into something you cannot see. And in that moment, it's already over. But the real reason this works so well is even more surprising. Light. In the deep ocean, light is rare. Sunlight barely reaches these depths. So anything that glows stands out. And the siphonophore uses this to its advantage. Through a process called bioluminescence. It produces its own light. Soft pulses. Flickering signals. Almost like stars, floating underwater. To smaller creatures, this glow is irresistible. It could mean food. It could mean safety. It could mean other life. So they move closer. Curious. Unaware. And that's exactly what the siphonophore wants. Because just beyond that gentle glow, are the tentacles. Waiting.
Invisible. Deadly. But this is where things get even stranger. Some siphonophores don't just lure prey. They manipulate entire situations. When something gets caught, it struggles. And that struggle can trigger flashes of light. Rapid bursts. Like a distress signal. But it's not a call for help. It's bait. Those flashes attract larger predators. Fish. Sometimes even bigger hunters. They rush in, drawn by the signal. Thinking they've found an easy meal. But instead, they find something else trapped. And while they try to grab it, they brush against the tentacles too. Now the siphonophore has more than one victim. It didn't just catch prey. It used one animal to capture another. This is not just hunting. This is strategy. Layered. Calculated. Efficient. And it works. In the deep sea, efficiency is everything. Energy is limited. Food is unpredictable. Chasing prey wastes energy. But waiting costs almost nothing. So the siphonophore spreads its tentacles like a massive net. Sometimes forming vertical curtains in the water. Other times drifting horizontally with the current. Some even form spirals. Complex shapes designed to intercept anything that passes through. This would be like stretching invisible fishing lines across an entire highway. Except every line is covered in venom. And nothing can see them. But perhaps the most unsettling part is how other animals respond. Scientists studying deep-sea ecosystems have noticed something unusual. Areas where siphonophores are common feel different. Not to us. But to other creatures. Fish avoid certain regions. They swim more cautiously. They change direction suddenly. Almost as if they sense something. But how do you detect something invisible? Something silent? Something that doesn't move? The answer lies in evolution. For millions of years, creatures that failed to detect siphonophores didn't survive. Only those that reacted, even slightly, lived long enough to pass on their instincts. So now, even without seeing the threat, they behave differently. Because somewhere deep in their biology, they remember. And that's what makes the siphonophore so powerful. It doesn't just hunt bodies. It shapes behavior. It changes how entire ecosystems move. To understand this fully, we have to go back. Way back. The siphonophore is ancient. Its lineage stretches back hundreds of millions of years. Long before sharks ruled the oceans. Before whales existed. Before most modern marine life. It evolved in a world where survival meant innovation. Where efficiency was the difference between life and extinction. And instead of becoming faster or stronger, it became smarter. Not in intelligence. But in design. A modular organism. A colony that acts as one. A predator that doesn't need to chase, because the world comes to it. And evolution kept refining it. Perfecting it. Turning it into one of the most effective hunters the ocean has ever seen. But even now, we are only beginning to understand it. The deep ocean remains one of the least explored places on Earth. We know more about distant planets than we do about the ecosystems beneath our own waves. And creatures like the siphonophore are a reminder of that. Because every time scientists study them more closely, they uncover something new. Something unexpected. Something that challenges what we thought we knew about life itself. But all of this leads to a deeper question. If a creature like this can exist, so efficient, so invisible, so alien in its design, what else is down there? What other silent hunters are drifting through the dark right now, unseen, unknown, waiting? And just when you think you understand the siphonophore, it reveals something even more unbelievable. Something that completely changes how we define an individual. Because this creature is not just a colony. It is something far stranger.
In the ocean, we like to think in simple terms. One body. One brain. One life. But the siphonophore breaks that idea completely. Because what looks like a single creature is actually thousands, living as one. Each tiny unit, each zooid, is genetically identical. Clones. Born from a single original organism. But instead of separating, they stay connected. Growing together. Specializing. Becoming something greater than themselves. Some zooids form the float. A gas-filled structure that keeps the colony suspended in the water. Others become swimmers. Pulsing rhythmically, to move the entire organism. Some handle digestion. Breaking down prey, and distributing nutrients across the colony. And then, there are the hunters. Long, lethal zooids, armed with tentacles. Each one loaded with thousands of microscopic weapons. Each one ready to fire. But this is where things get even more bizarre. Because no single part of the siphonophore is fully in control. There is no central brain. No leader. No command center. And yet, it behaves with coordination so precise, it feels intentional. Like a perfectly synchronized machine. To understand this, imagine a city. No government. No central authority. But every citizen knows exactly what to do. Traffic flows perfectly. Resources are distributed flawlessly. Everything operates in harmony. That's the siphonophore. A decentralized life form. Running on simple biological rules, that together create something incredibly complex. But the real reason this matters, is because it changes how we define individuality. Where does one organism begin, and another end? Is the siphonophore one creature? Or thousands? Science still debates this. Because technically, each zooid is an individual animal. But together, they cannot survive apart. They are both, one and many. At the same time. And that's not just strange. It's revolutionary. Because this kind of organization may represent one of evolution's most powerful strategies. Instead of building one complex body, build many simple ones. Then connect them. Coordinate them. Turn them into something greater. It's modular life. Flexible. Adaptable. Efficient. And in the deep sea, efficiency is everything. But the siphonophore doesn't just survive. It dominates. Some species grow to incredible lengths. Over 40 meters. Longer than a blue whale. Making them some of the longest animals on Earth. Imagine drifting in the dark, and encountering something longer than a bus, yet thinner than your finger. A living line of death, stretching endlessly into blackness. But length isn't the only advantage. Because the siphonophore's body is constantly changing. As it grows, new zooids are added. Specialized. Positioned. Optimized. It's like a living assembly line. Continuously building itself, for maximum efficiency. And if part of it is damaged? It doesn't panic. It doesn't fail. It simply regenerates. Replaces what's lost. Reorganizes. This resilience makes it incredibly difficult to defeat. Because there is no single weak point. No heart to stop. No brain to destroy. Just a network. A system. A colony that keeps functioning. Even when parts are gone. And that's not even the most unsettling part. Because siphonophores don't just passively drift. Recent observations suggest they can actively control their position. Adjusting buoyancy. Altering movement. Even coordinating swimming pulses. Not fast. Not aggressive. But deliberate. Like a slow-moving trap, constantly repositioning itself to where prey is most likely to be. And in a world where food is scarce, that's a massive advantage. But the real shock came when scientists started studying their hunting patterns more closely. Because it turns out, they may be far more selective than we thought. Certain siphonophores appear to target specific prey. Adjusting their structure. Their depth. Even their behavior. To maximize success. This suggests something extraordinary. Not intelligence in the traditional sense. But a form of biological optimization, so refined, it mimics decision-making. Like a living algorithm. Input, environment. Output, survival. And it has been running this program for hundreds of millions of years. But all of this leads to a bigger realization. The siphonophore is not just a predator.